This wasn't working earlier today. Oh, now it is. Good. It's recording. Okay. So this is 8th grade, lesson 5-2, solving systems by graphing. If you were absent, and I got students that were absent, I'd really recommend that you watch yesterday's video so you're not completely lost in what we're doing here. It says solve a system by graphing. And so we've got company A here and company B, and then the information they give us here, they come up with two equations in step 1. Y equals 0.2x plus 75, and the other one is y equals 0.25x plus 70. And so here's the two equations right here. And step 2, it says to graph it. So you guys, everybody should know how to graph. And so here's the cost along the y-axis, here's the minutes used along the x-axis, and they graph it for us. And they point out at the point of intersection right here, that's a solution to both of these equations where the lines intercept one another. And so there's one solution for this system of equations. So to try it down below here, it says solve the system by graphing. So let's do this one together. Now, sometimes you'll have a graph, and this is a good example, where the equation you're trying to graph doesn't really fit on the graph. So look at this one for a moment here. Let me zoom in a little bit more, and we'll do this together. I'll use green for this first one. So y equals 3x plus 5. Okay, so let me pull a stick here. And I'm going to ask the question. That's 8th grade. In that very first equation, Mr. Webster, what's the y-intercept? The 5. Okay, so here's this graph. It's all the way at the top right here. 5, that's the y-intercept. And what's the slope? Mr. Webster? The 3. Okay. So normally when I'm talking about a slope, if this was my graph, and let's say my starting point was, I don't know, let's say it's right here. It's 3, it's not -3, so I'm just going to go over 1 and up 1, 2, 3. And then over 1 up 1, 2, 3. So there I've plotted my points. Well, our starting point is at the top. So it's not going to work. I can't go up any further. So I'm going to, instead of, it's going to remain a positive slope of 3, but I'm going to go over 1 to the left and then down 3. 1, 2, 3. Over 1 to the left and down 3. 1, 2, 3. So there's my points on a graph. And I can just quick line. And you can see it's a positive slope. It's going up from left to right. And it is a positive slope. And now I have it on my graph. But if I started here, like I said, it would be really kind of awkward. So you'll have problems like that once in a while, where your starting point, it's going to take you right off the graph. But then just draw the line in the other direction, like I did here. I'm not going to start here and draw my positive slope above my graph. I'll just do the opposite. Instead of going over 1 and then up 1, 2, 3, I went over 1 to the left and then down 3, over 1 to the left and down 3. So you'll have some problems that are kind of funky like that. So that's the first one drawn. Let's look at the next line. All right, Mr. Webster, put up 50 points. Let's see here. Mr. DeWoody, I know you weren't here, but give it a shot. What's the y-intercept for this equation right here? 4. It's 4. So it's a little bit lower. So it's right here. And what's the slope? Yeah. It's 2. So again, it's the same problem I had with the first one. I can't go the slope is 2. I can't go over 1 up 2. I mean, I could, but I'm immediately off the graph. So I'm going to go not over 1 to the right, go over 1 to the left, and then down 2. Well, that's going to be right there. And then over 1 and down 2. Over 1 and down 2. Okay? And so I can draw my line. Looks about like that. Didn't come out very well, but you get the right idea. Okay? Now, when I went over 1 and down 2, I landed right here where I had put a dot previously. And so you can see that these two lines, they do cross one another. And so the solution is the point of intersection. And so what is that? Let me pull a stick here. Oh, yeah, put up 50 point, Mr. DeWitty. Miss Johnson's not here. Yeah, I don't think she's coming back. Mr. Gunn's not here. All these students that are absent. Miss Carpenter. Miss Carpenter, what is that point right there? Well, then sit somewhere where you can see it. Okay, Mr. Atwood, what's that point?
2 and -1.
No. Mr. Perry, first day I know, but can you tell me what the coordinates are for that point? It's okay if you don't know, just say, what, say it again? Nicely done. X value first. Remember, X is always first, Y is always second. And so it's -1 and then up 2. -1, comma 2. Okay, nicely done, Mr. Perry. What group are you?
I think it's group 3.
I think you guys are group 3. So somebody show him how to put up 50 points for group 3. Okay?
How do you do the negative? I just changed the number from -200 to -150.
You just erase it to go -100.
All right. All right, example 2. I'll let you guys look at that. It's to solve the system. So again, you're just going to do a comparison here. And actually, they do it for us, and you end up with 2 parallel lines. And so there's no solution because they never touch. And example 3, again, they do it for us here. You've got 2 equations that you'd have to convert both of them into y equals mx plus b. Once you have them both in the point slope formula, then you can do a comparison. And in this case, it's the same line. So I want you guys to do the triad here. So circle A and B. Raise your hand if you're confident. Let's just look at A for a moment. If you're confident that you could figure these out, these two. Raise your hand. So only 1, 2 of you. Okay, then let's do it together here. Let me get my sticky note. Okay. The first equation we're looking at is 5x plus y equals a -3. 5x plus y equals a -3. And remember, our target is getting it in the form of y equals mx plus b, because once it's in that form, then we can graph it. All right? So I'm going to get y by itself. So I'm just going to start off by subtracting 5x. And whatever you do on one side of the equation, you do on the other. They cancel out. So now I'm left with y equals a -5x. Looks like -3. Now it's in the form of y equals mx plus b. I could graph that. So I could add some graph paper. Here's my graph paper. The y-intercept is -3, so I could just go down 1, 2, 3. And the slope is -5, so I'll go over 1 and down 5. 1, 2, 3, 4, 5. And I could go, in this case, over 1, up 5. 1, 2, 3, 4, 5. All right, so there's an approximate of my line for that first equation. Just going to draw a line there. All right, so that represents the very first equation, which was a 5x plus y equals a -3. Well, let's do the next one. The next one is 10x plus 2y equals a -6. All right, pulling a stick here. Mr. Slickman, any idea what's the first thing I would do to get it in the form of y equals mx plus b?
Subtract from the y.
No, good try.
Oh, you got,
You want to get rid of that 10x. Miss Anderson, what would you
Huh? Oh, okay. You would do 10, okay, 10x minus 10x. Will you do like the subtraction of like 10, you know?
subtract 10x on both sides?
Yeah, sides.
They cancel out, so now I'm left with 2y equals
-4.
-10x
Oh, yeah.
minus 6. Okay. Question?
We're subtracting 10 from 6. Why is it not -16x?
So,
Oh, I know that.
so because for starters, they're not like terms. You can't subtract the 6 from the 10 because the 6 doesn't have an x. Remember, you can only work with like terms if as far as adding or subtracting. Okay? So, just to back up, so if I had like 3x minus 1z plus 2y plus 3x, and I said to simplify that, you want to look for like terms. We have a 3x and a 3x. I mean, it could be a 2x or a 1x or whatever, so that would be 6x. There isn't any other z, so that's just going to be minus z plus 2y. So remember, when we're converting equations into the form of y equals mx plus b, you can't do anything with those two because they're not equal. They're not the same terms. They're not like terms. The 6 doesn't have an x. But we're not done because we don't have y by itself. What's happening to the y? It's being multiplied, so we divide each side by 2. They cancel out. So now we're left with y equals, well, what's a -10 divided by 2? -5x. And what's a -6 divided by 2? -3. Now it's in the form of y equals mx plus b, or in this case it's -3. So we can graph this one. Y equals a -5x minus 3. So here's my graph. Y equals a -5x minus 3. So minus 1, 2, 3. So it's the same starting point. And what's the slope? -5x. What was it up above?
-5x.
What do we have here?
The same.
The same line. So it says describe the solutions. And so for A, I would just put infinite many. Because it's the same line. Okay? So there's A done for you. Okay. Turn to page. I'm looking at page 276. So I scratched out one, but I did want you to do it. And the answer is right there. The solution of a system of linear equations is the point of intersection. And so here's an example of I went through these in detail yesterday. Here's one solution, two different lines, and they cross at one point. Here's infinite many. It's the same line, one on top of the other. And then here's no solution because they never, ever touch. Number two, if a system has no solution, what do you know about the lines being graphed? Well, no solution, guess what? They're parallel. They'll never touch. And number three, in a system of linear equations, the lines described by each have the same slopes. What are the possible solutions? Well, I just put down one. They could have infinite many if they have the same y-intercept. But also, they could just have one solution. So one of those would work. Circle 4, 5, and 6. I want you to do those. 7, 8, and 9. 9, I went over this briefly with you. There's two rivers, River Y and River Z. River Y, the cost is $33. Let's look at that for a moment. The cost is $33. So, if my equation is the cost is $33, so it's y equals 33. That's my equation. If we were to graph that right here, looks like these go in increments of 3. So 24, 27, 30. This would be 33. So if y equals 33, here's how I would graph it. There it is, right there. Doesn't matter what x is. X could be 4. What's y? 33. If x is 10, what's y? 33. Doesn't matter. Now what you will need to do is graph this. See, the cost is 5n plus 13. Okay? You should be able to graph that. And of course, c is in place of y. So then it says for B, graph the system of equations. Well, I just did one of them for you. I'd graphed y. Now you're going to have to graph z. And then once you do that, you time, and if it's maybe 8 hours or 2 hours, I don't know. You'll have to figure that out. Circle 10 and 11. So let's, I don't know, I'll do one more with you guys here. Let's do 10 together. Part of it. So here's the two equations. X plus 2y equals 4. X plus 2y equals 4. All right, I need to get y by itself, so I'm just going to get rid of the x for starters. So now I have 2y equals a negative x plus 4. Okay? Now I want to get y by itself. Divide each side by 2. They cancel out. I'm left with y equals. Now there's always an assumed 1 in front of every variable. So I could look at this as 1x. It's a negative 1 divided by 2. Well, I could just write it as a negative 1/2 x, and 4 divided by 2 is 2 plus 2. So there's the first equation. And I'll just put it up here. Y equals a negative 1/2 x plus 2. So that first one is done for you. So now you need to figure out the second one. I think you guys can do that on your own. Okay, page 278. Let's take a look at that real quick. Circle 12 and 13. 14, A and B. And then 15, multiple choice. And then 16, what's the solution? And that's it. So you guys have some time to work on this.